Let's solve one previous question of mathematical logic. This question was asked in GATE CS 2015 set 1, question number 28. The binary operator not equals to is defined by the following truth table. This is the truth table for not equals to. Here this symbol means not equals to. Okay, this is just a binary operator and truth table for it given. Which one of the following is true about the binary operator not equals to, and 4 options are given. Now analyze the truth table. When P0 Q0 is 0, when P1 Q1 is 0. So when both have same truth value it's 0, and when both have opposite truth value, like for P0 Q1 it's 1, for P1 Q0 it's 1. So when both have opposite truth value it is 1, and when both have same truth value it is 0. So it's like XOR. In case of XOR, if both have same truth value then it's false. If both have opposite truth value then it's true. Now check P not equals to Q. When P0 Q1 it will be 1. Now reverse it. So Q not equals to P. When Q1 P0 it also 1. So it is commutative. As it's same as XOR, XOR is commutative. Now check the associative. Let me take three propositional variable P, Q, R. P is 0, Q is 1, R is 0. So 0 not equals to 1 it will be 1, then 1 not equals to 0 it's 1. Now when we will do Q not equals to R first, so it will be 1, then 1 with 0 it will be 1. In both cases it is same. Let's take another example when P0, Q0 and R1. Now P not equals to Q it will be 0, R is 1. 0 not equals to 1 it will be 1. Now Q not equals to R, 0 not equals to 1 it will be 1. Then 1 not equals to 0 it will be 1. Hence it proves that it's also associative. It's same as XOR. XOR is both commutative and associative. That's why this not equals to also both commutative and associative. So here answer will be option A, both commutative and associative. I already discussed propositional logic. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you.